Okay, good morning, everyone. So today we've actually finished the syllabus that we were supposed to finish for this term. So today we're just going to do some questions.
Three chapters only.
Sorry?
3 chapters only.
You mean what, for exam, if you have exam?
Yeah.
No, including last year's ones?
Wait, what?
Including last year's ones?
Really?
Yeah. Okay, so we will go through some of the review questions from last week. Okay. Okay, any question in particular? So last year's review questions was taken from your textbook, page 178. So I've already uploaded the answers as well on Edmodo. So Elijah, just now you were asking for which question specifically?
Answer 6.
Question number 6.
A.
6A, okay. Let's look at the question. Everyone, please make sure you turn to page 178 of your textbook. Question 6A. A student wants to find the density of a brick. He measures the side of the brick. What is the volume? So volume will be length times breadth times width, which is 20 times 10 times 6. Oh, the answer given is wrong. 200 times 6, 1200 centimeter cube. Is that what you got?
Yeah.
Okay. Should be 1200 centimeter cube then.
And 6B also, isn't it 0.2 grams per cm cube?
He measures the mass of the brick, finds that it's 0.24 kg. What is the density? So if you take in kg, it will be 0.24 divided by 1200. What did you get?
I used the grams and I got 0.2 grams per cm cube.
Yeah, correct. If you use the volume 1200, then your answer should be correct. Huh? Okay, anyone else have any other questions from last week's review questions?
So can you please explain 3B?
Okay, two glasses are filled with liquid to the same height. Glass W is filled with water, glass F is filled with fruit juice. Fruit juice has a higher density than water. So if fruit juice has higher density than water, when I mix the fruit juice and water, which one will sink to the bottom? The fruit juice or the water?
Fruit juice.
Yes.
Fruit juice.
The one with the higher density will sink to the bottom because they are essentially heavier. So write the lattice to show this pressure in order from lowest to highest. Okay, so pressure at the bottom of glass F, pressure at bottom of glass W, pressure halfway up glass W. So we must remember that the height of the liquids in the glasses are the same. Okay, so because fruit juice is denser, okay, because fruit juice is denser, automatically W is going to have a, let's see, lowest to highest. Okay, so when we look at liquid, what is the formula for liquid? A pressure of liquid. Anyone? What is the formula for pressure of?
P times H times G.
Force over area.
That is not liquid. Force over area is for a solid.
P times H times G.
The pressure of liquid is H height, which is the depth of the liquid, times density of the liquid, times G. Okay?
So G stands for gravitational, Acha, but what does gravitational mean?
The gravity that is exerted on the liquid.
How do you measure that? Or will the exam question give?
That is a given. It's a constant. Okay, so we know that pressure of liquid is H rho G. Density is the symbol for density is rho. Okay, so it's not yeah, it's not yeah. Okay. Okay, so we have pressure equals to H rho G, which means the deeper the liquid, the higher the pressure. The higher the density, the higher the pressure. I'm saying this based on the formula itself. Okay, the deeper the depth of the liquid and the higher the density, the higher the pressure. Because when I multiply everything together, I get a bigger volume. I get a bigger pressure. So I want to see order from lowest pressure to highest pressure. Okay, so lowest pressure would be the pressure halfway up glass W. That would be the lowest first. Why? Because if I have a glass, I have a check here. In a glass, compared to when I have a glass halfway and a glass full of liquid, the one with half will have a smaller depth, which means the pressure will be lower. Okay, I just want to answer a chat. Okay, so let me just draw this. Okay. Okay, does everyone see the white screen? Yes?
Yes.
Okay, so I just want to draw. Okay, so let's say I have a glass here and a glass here. Okay, we'll do it this way. So I have glass F, which is filled with water, and glass F is filled with fruit juice, and glass W is filled with water. Okay, so they both have the same amount of liquid inside. Okay, that's what the question has given us. F is fruit juice, W is water. Now let's look at B. So I have three situations. Pressure at the bottom of glass F, pressure at bottom of glass W. I'm just marking where the pressures are at. Pressure halfway up glass W. So halfway means maybe here. Okay, so now we know. Yes.
I can't see anything of what you're writing.
Anyone else?
You can't see anything you're drawing. I can't see anything either.
Yeah, just blank.
Same chair.
Just white stuff.
Maybe check the color of your pen. Maybe it's white. I don't know. I've not used this feature before.
Let me try it. Can you see now?
Oh, we're back.
Yes.
Yay.
Yeah.
Can see the thing? Can see the drawing now?
Yeah.
Now?
Can see.
Yeah.
I
Okay.
could see it.
Okay, so now I have glass F and WF is the fruit juice and W is the water. So I've marked the points that are stated A, B, C. So A is here, the bottom of glass F. B is bottom of glass W, so here. And then this is C. C is midway glass W. So now we know that pressure in liquid is H rho, and G. Okay, H is the height of that means the depth of the liquid. So the deeper the liquid, this number is going to be bigger. When I times, I will get a bigger pressure. That means the higher the height, the larger the height, the deeper the depth of a liquid, the higher the pressure. So in this case, the lowest pressure is going to be C because the height is only half of the depth. Okay, compared to the full depth, okay, half of it. So this is going to be the smallest pressure. Everyone understand so far? Anyone confused? No? Okay, I'll take that as a no. So C is first, okay, because the depth is smaller. And then between B and A, okay, then we have information about the density. The larger the density, the larger the pressure as well. Okay, so between fruit juice and water, they say that fruit juice has a higher density. Why we are comparing density? Because now both the depth at A and B are the same. So we cannot compare the depth, we have to compare the density. So water has a smaller density. So this will be second. And then the largest will be point A because fruit juice has a large density. So from lowest to highest pressure will be C, B, and then A. Okay, can understand?
So you can please again about the CBA.
So C is at midway of the glass. So midway of the glass means the height is not much. It's lesser than the height until the bottom. So when the height is smaller, the pressure will also be less. So that's why C is the lowest.
Okay, I understand.
And then between B and A, B is smaller because the density of water is smaller. So the pressure at B is smaller. And then followed by A, which has the higher density. Okay, can understand? Yeah? Okay, any other questions from the review questions?
So I'll go through 13B.
13B. Okay, everyone look at 13B. Jamal sits at the end of the seesaw. Jamal has a weight of 200 Newton. Now let's just draw this. Okay. So let's say I have, who wants to volunteer to draw the situation? Then you can draw on my screen. Who wants to draw? Raise your hand. Yeah, I'll call out someone. Okay, I'll call out someone then. Isabel, draw question 13. Draw it out. Do you know how to use the pen on your screen?
No, sir.
So you go up to where it says chat and everything. There's one that says, do you see annotate or do you see whiteboard?
Your file.
No. You're on your Zoom itself. There is mute, there is video and all, right?
Mm-hmm.
So do you see something called annotate?
No.
How about whiteboard?
No.
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 Okay, does anyone have annotate? Is anyone able to draw on my screen? Or all cannot draw?
So there's participant. So
Sorry?
there's participant, chat, share screen, record, reaction.
Sorry, participant, reaction, some more?
Chat,
Mm-hmm.
record, share screen.
Annotate don't have.
Don't have.
Under more, do you have a button called more? No.
No. Oh, annotate actually.
Yeah, annotate.
God.
Okay, so you click that. And then you'll be able to draw it right and see. Right on my board. Yes. Okay, so you clear and draw the question 13 out. So you draw a seesaw, Jamal sitting on one end, and he has a weight of 200 Newton.
Cacat never mind lah, Cher.
Never mind, it's okay. This question is on the subtopic of moment. So remember, moment is force times distance. Since this one doesn't have distance, then we will have to look at it. Let's see.
Cher, masa label.
Yeah, label the 200 Newton.
Never mind.
So this one we look at, since we don't have distance, so we look at it logically. So instead of looking at moment, we look at center of mass and stability. We look at that concept, since there is no distance.
200 Newtons. Cher, done.
Done? Okay, thank you. Okay, so now we have the seesaw. Okay, we have 220 Newton because it says at 200 Newton. Let me just correct that. It's 200 Newton. So this is at the end of the seesaw. This is where Jamal is sitting. Okay, so seesaw usually the pivot is in the middle lah. Okay, so the distance here and the distance on the other side will be the same. Because seesaw that is in the middle. Okay, so now Jamal's brother has a mass of 400, so it's double of 200. Okay, so if let's say Jamal's brother, so they're asking, he tries to balance the seesaw. Where should he sit to make it balance? So let's say Jamal sits at the end. So he sits here. So 400 Newton here. What will happen to the seesaw? What will happen to the
He
seesaw?
moved to the 400 weight.
Correct. So it will move anti-clockwise this way. It will move down this way because here is obviously heavier. So in order to make it balance, what do I need to do? Or what does Jamal's brother need to do?
Get someone in the 200. Move closer to the pivot.
Yeah. So he can't get someone in this case because it says where should he sit? So go closer here lah, towards the pivot. And because it's double 200 to 400 is double the weight. So because it's double the amount, so
You
where,
divide the distance lah.
yeah, you divide the distance. So it is halfway here. So half the distance here. So between the pivot and the end of the seesaw, halfway through is where Jamal's brother should sit. Yeah? So that he can balance the seesaw. Okay, can I understand? Of course, the other, if I were to balance it, I would also want to put another 200 Newton here. That will also keep it balanced. But in this case, it says where should the brother sit? So halfway lah. Because 200 is half of 400. So I also take half the distance. Okay, can? Okay, any other questions? No? You all need to respond. No, I won't know.
No, sir.
No?
Not sure.
Not sure.
Okay. Okay, so if that's the case, then we will do some questions now. Okay. Just give me a moment. Okay. So, we'll go through our workbook questions first. Okay. So we'll try and finish the ones that we haven't done yet. Okay, for those who have your workbook, have you all done page 79? Can you just quickly check?
No, sir.
No?
No, sir.
Okay, so you can do page 79. For those who don't have your workbook, I'm going to take a picture and send it into the group. Okay, I've just sent it into the group. Okay, please do now. Those who don't have your workbook, you write in your exercise book the answers, and then we will go through it in a while. Okay, you can start doing. It's 9:40 now. I'll give you 15 minutes. So 9:55 we discuss. Okay, so who wants to try? Okay, Aaron, look, try.
Okay. The first one is machine. Then acts as a force. It's a multiplier.
Aaron, can you read the whole thing? Read the whole
Okay.
passage.
A lever is a simple machine that acts as a force multiplier. The lever turns about a load. The force that you apply is called the effort, and the force that is produced is called the load. To use a small force to lift a big weight, you need a lever where the distance between the and this Shreya, this is the part where I'm slightly confused with.
Okay. Okay, thank you, Aaron. So let's just go through it again. I repeat. A lever is a simple machine. You can mark your work, okay? It's a simple machine that acts as a force multiplier. Correct? The lever turns about a pivot. Okay, it turns about a pivot. It turns about a fixed point. So you need a fixed point for a lever to work. So it turns about a pivot. The force that you apply is called the effort, and the force that is produced is called the, what did you say just now?
I say it's called the load.
It's called the load, okay? To use a small force to lift a big weight, you need a lever where distance between the, okay, anyone else wants to try this part?
You can try.
Can.
Um,
I read from to use a small force.
Use a small force to lift a big weight. You need a lever where the distance between the effort and the pivot is bigger than the distance between the load and the pivot.
Correct. So to use a small force to lift a big weight, you need a lever where distance between the effort and the pivot, or pivot and the effort, whichever way, is bigger than the distance between the pivot and the load. or load and the pivot. Like the spanner at the bottom, okay? You want to use a small force, the distance between where your hand is and the pivot must be bigger.
Okay, thank you, Chair.
Okay. Okay, anyone did not get that or wants me to repeat anything? Okay. Next, what is meant by a turning force? Oh, okay, someone asked me to repeat. Okay, I'll just repeat one more time the paragraph. A lever is a simple machine that acts as a force multiplier. The lever turns about a pivot. Pivot is a fixed point. The force that you apply is called the load. The effort. And the force that is produced is called the load. To use a small force to lift a big weight, you need a lever where distance between the effort and the pivot is bigger than the distance between the load and the pivot. Pooja, did you get that? Okay. So next, what is meant by a turning force? Kavishka.
Okay. When you push on one side of the lever, you produce a turning force. So it's like a moment of
A what? A moment?
the moment of a force.
Okay. So can you repeat the first part of your answer?
Wait, I'm trying to make
Okay.
Yeah, I just wrote the moment of the force.
Okay.
when
Your first part, Kavishka.
when you push down on one side of a lever, you produce a turning force.
Okay. Yeah. So essentially, it's that lah. So when you have a movement of force applied to a lever, you will produce a turning force. Or you can also say moment of a force. That would be the definition of it lah. Okay. So what is meant by a turning force? A turning force is basically when I have a lever and I apply force to it, and that causes movement. So that movement is known as the turning force. Okay, next. Where is the pivot in the diagram of the spanner? Label it P. So it will be at the center of the nut. Okay? That's where the pivot is. Which letter A, B, or C is the pivot in the diagram of the door handle? Between A, B, and C. Let me call Sureka.
A?
Yes, correct. A. That is the...
Where is... So for 2B, where's the pivot again?
The center of where the nut is.
Why, Acha?
Because that part is the one where you have a spanner, right? And then you have the nut here. Then you're turning it this way, what? So the fixed point is where the nut is at. The nut is the load, but then at the center point there is where the pivot is.
So, but you know, if in exam, if you ask us to label stuff and then you give us different objects, then how would we know where the pivot is? Is there like a certain method to know?
No, you have to imagine using the tool.
Oh, okay.
So it will be tools that you have seen before lah. So you have to imagine, okay, if I were to push a wheelbarrow, where would the pivot be? If I were to unscrew this nut, okay, where would the pivot be? Even for the paint tin also, okay, if I were to lift up the cover, where would the pivot be? You have to imagine it. Okay? Yeah, let me just answer a question in the chat. Okay, next. Where would you apply the force to the door handle? Let me call someone. Abigail, where would you apply the force to the door handle?
C.
Correct, C.
I put B and C.
Okay, but if you were to choose one, would you choose B or C?
C.
C. So it's towards the end lah. Okay. What would you notice if you applied it at the other label point?
The door won't open. If
Uh,
you try to turn it at A, you'll have difficulties opening it.
Okay, so which means you will have to put more force. So the closer you are to the pivot, the more force you need to put, which is what we talked about in the paragraph. If you want to use a small force, you need to make your distance between the effort and the pivot to be as far as possible. So if you were to put nearer, you will have to use more force. You need to apply more force. So in this case, for E, what would you notice if you applied it at the other label point? You would need to apply more force to turn the handle. Okay. Okay. Now, if you have other answers, right? Okay, try to just mention it here, just so that your other friends can also like learn from you. Okay. If you have other answers, instead of typing it in the chat, you can ask me straight away here itself because we're discussing anyways. Okay. Okay, number 3. It is much easier to open a tin of paint with a screwdriver than with your fingers. So label the pivot in the diagram. Let's see. Ricardo.
Right at where the screwdriver is going into the lid of it.
Not quite. Not the point where it's going into. Imagine you're trying to flip the cap up. Flip the top part of the cover of the tin. Okay. So if you were to flip the cover of the tin,
That's
the
right.
part, correct. So where would it be?
In between the screwdriver, like in the middle point.
Yeah. So where the screwdriver is resting on the tin, that will be where your pivot is. Because when you try and flip open the tin, it will the fixed point will be where it's resting on.
Okay.
Okay. So that will be your pivot. Draw an arrow to show the distance from the pivot to the load. So you just draw lah from the pivot of the point to where the screwdriver is touching the lid, because the lid is where your load, the lid is your load. So it's that very tiny distance between the pivot and the tin, where the screwdriver is touching the tin. Okay, draw an arrow to show the distance from the pivot to the effort. Now, where is the effort, Isaac? Where is your effort?
On the handler, teacher.
The handle. So the distance between the pivot and the handle, you draw an arrow to show that is your distance between from the pivot to the effort. Okay, last one. Use what you have done to explain why the force you need to open the can with a screwdriver is very small.
Because the effort is far from the pivot and the load is much closer.
Correct. So the distance from the effort to the pivot is much greater than from the pivot to the load. So you only apply a small amount of force. Okay, a small effort to produce a large output force. Okay, so the further the effort is from the pivot, compared to the distance between the pivot and the load, the lesser work needs to be done to get the lesser force is needed to get the job done. Okay, anyone lost? Anyone needs any repetition? No? Okay, so just remember your pivot for the third one is where the screwdriver is resting on the tin. Okay, because you want to flip the can open, it has to, the effort there, your hand will move down, but then it will be resting at the fixed point where the tin is. Okay, the last one, what have you done to explain why the force you need to open the can is small? Because the distance from the effort to the pivot is much greater than the distance from the pivot to the load. So you apply a small effort for a large output force. Okay, that is in relation to what we looked at in the paragraph. It's the same idea, same concept. Okay, so I'll give you all a break, a 10-minute break. You can go to the washroom, go and get a drink or something, and then come back at 10:20. Okay? And then we'll continue.
I'm back.
Okay.
Yes.
I'm here, Chair.
Okay.
I'm here also, Chair.
Here, Chair.
Okay.
Here, Chair.
I'm here.
Okay. Okay.
Here, Chair.
Here, Chair.
Okay. Malcolm, are you here? Not yet. Oh, okay, he's here. I think the rest I've heard. Isabel? I didn't hear Isabel. No, Isabel's not back. Celeste? Celeste, are you back? No, not yet also. Let me call Isabel. Isabel, are you here? Are you back?
Yeah, sure.
Okay. Celeste? Celeste still not back. Oh, okay. Celeste is here. Okay, mic not working. Okay, so next will be I'm going to give you all another set of questions, not from the workbook though. So I'm going to send a link on WhatsApp. Okay. Yeah, I'm going to send it to the group. So you click on the link and then it'll bring you to a set of questions. So let me just quickly send you the link, okay? It's on density. If there are 12 questions. Okay, you'll need your calculators for this, so please make sure you have your calculator.
So do we do it in our workbook?
Yes, do in the workbook. Okay, I've sent you the link. Can you all please click on it and let me know that if it's working or not, as in you all can see the questions.
Yeah, Chair, can.
Can, Chair.
Yeah, I can, Chair.
Okay, so please do, and then we will discuss.
Chair,
Yes?
okay, for your class, Chair, you know if we get decimal point, we run it up to the second decimal place, right?
Can, yeah.
Okay.
Okay, for
Should I write the answer in the exercise?
Please do working also. For those of y'all who cannot access it, okay, I will put it on the screen. Okay, I think so far only one of y'all.
Sure, I cannot open.
Cannot open also. Okay, I'll put it on this screen. Okay, can you all see the questions?
Yeah, sure.
Can see the density calculation? Okay. I will have to scroll down. So once you all are done, so far those who are looking at my screen is Celeste and Isabel. So Celeste and Isabel, once you all are done with question 5, then let me know and then I will scroll down. The rest you can view it from your phones.
Teacher,
Yes?
so like let's say if we do like over volume, the volume is cm cube. So use gram. Then for kg we use meter.
No, you can leave it as cm cube. So your density will be gram per cm cube.
But what if we give a kg?
See, in exam, will you ask us to change?
Wait, Elijah.
Sorry,
Let me
sorry.
finish with,
Sorry.
Siva first. Okay. If kg means, then kg per cm cube. Unless the question says, okay, I want the answer in gram. Then you change kg to gram.
Oh, okay.
If not, if let's say you take gram over cm cube means, then gram per cm cube. If kg over cm cube means, then kg per cm cube. Okay. Yes, Elijah? Elijah, you had a question? No, Elijah, no question? Elijah, are you there?
Yes, sir.
You don't have a question. You had a question just now?
Yeah, sir. So sorry. Will in exam will you ask us to change like cm cube to meter cube or something like that?
If let's say I want the answer to be meter cube, then you have to change cm to meter cube lah. So 8 cm cube, we change it to meter cube.
Sure.
Yes.
For question 2, they never gave the dimensions for the volume. So how do we find the volume, sir?
So I have 50 milliliter container with 43.5 gram of cooking oil. What is the density of the oil? So 50 milliliter, you change to volume. What is the conversion from milliliter to volume? You learn this in
Shall I do that?
maths.
Okay.
Jared, can you not put the mic so close to your mouth?
So 1 milliliter is 1 cm cube. So it's 1-to-1 conversion. So 50 milliliters will be 50 cm cube.
Okay, Chair.
Kavishka, number 10. Okay, no. Oh. Okay, so she didn't do number 10. Okay, anyone wants to try number 10?
So, is it like we have to find the initial and the final thing and minus?
Yeah, correct. So I have a cylinder and it's when it's empty, it's 50 gram. Then
Yeah.
30 ml of water is added, and then now the mass is 120. If I put a rock to into the cylinder, the water level rises to 75. So from 30, the water will rise to 75, which means
So
what is the volume of the rock?
75 minus 30,
Correct?
45. Then 250 minus 120, 130. So you divide, you get 2.89 grams per
Correct.
ml.
Yep, correct. 2.89 grams per ml, correct.
So how is it 2.89?
So the volume of the rock is 75 minus 30.
Yeah.
Okay, and then I want the mass of the rock, correct? So the mass of the rock is, when the water is in without the rock is 120. When you put the rock in, it becomes 250. So the mass
So
of
we
the rock,
minus it lah.
yes, 250 minus 120. Okay, number 11, a student performs an experiment with 3 unknown fluids, obtaining the measurements. Draw how the fluids will be layered. So we know that the denser one will be at the bottom, the second less dense will be in the middle, and then the least dense will be at the top. So the first thing I want to do is I want to find the density of the 3 liquids, okay? So let's see. Okay, Ricardo, what is the density of fluid A?
1.03 grams / ml.
Okay, so density of liquid A is 1.03. Density of liquid B, Ricardo?
0.79 grams / ml.
Okay, 0.79. And for fluid C?
0.9 grams.
0.9. Okay, so which one will be at the bottom?
A.
Correct. Second?
C.
Correct.
And then B.
Correct. So it will be A at the bottom, followed by C, and then B at the top, at the most top. Okay. Some of them asked for question 10. I'm just going to repeat question 10. So density of rock. Density is mass over volume. Okay. So the mass of the rock is 250 grams minus 120 grams, which is 130. The volume of the rock will be 75 minus 30, which is 45. Did you all get that, Isabel and Pooja? I should get the answer. 130 divide 45 is 2.89. 2.89 gram per ml. Okay, the last one. Okay, I have the densities. Now I need to I need to find out what each material is made out of. Okay, who wants to try?
Sure, the first one is copper.
Okay, so 26.76 divide 3. I got 8.92 copper, correct. Second one, the one on the right.
Is
What did you get,
quartz.
Kavishka?
Quartz.
Yes, quartz.
The quartz.
And then correct. The third one, the ring.
The ring one, I don't know, sure.
Okay, so I have a ring with a mass of 107 gram. I fill a cylinder up to 10 ml water. I put the ring in and then the water rise up to 15. So which means the volume of my ring is, what's the volume of my ring, Kavishka?
What's your? Couldn't hear you.
I fill my cylinder with 10 ml of water. I put the ring in, it becomes 15. So what is the volume of the ring?
15.
No.
Oh, no.
From 10, it rise up to 15. 5. So that is my volume of the ring. I have a mass of 107. So what will my density be?
Yeah, 21.4.
Correct. So what material is it?
21 platinum.
Correct. Okay, the last one, a block on your desk acts as a paperweight, measurement 3 by 4 by 6. So what is the material made out of? So 184.32 divided by 3 times 4 times 6, I get 2.56, which is marble.
So C is platinum, right?
C is platinum, yeah. The ring is platinum.
Okay.
Okay. Anyone have any questions?
No, teacher.
No? Okay. Then that is all for today. I will see you all in the next lesson. Just look out for homework on Edmodo.
Okay, sir.
Okay?
Okay, sir.
Bye,
Thank
sir.
you.
Bye,
Thank you.
sir.
Bye-bye. Bye.
Acha,
Yes?
so, I have some questions to ask you. Acha. Is it okay if I email you some questions? Because I don't think we're going to go back to school anytime soon. I kind of want to ask you a few questions. Is it okay if I email you sometime soon?
Yeah, can.
Okay, Acha.
Okay.
Bye, Teacher.
Thank you.
Okay, Acha, bye.
Bye. Bye.